Welcome to today's webinar, again hosted by the OTC community. As maybe already known, today again we have the ITS here in our round with the name here Victor, and in this case today Ilya, and also our well-known Uli from our Uli's Hands-On is also here.
Hello, everybody. Today's topic is about how you can secure your Open Telecom cloud using HashiCorp Vault in combination with Cloud Container Engine. Right now in Open Telecom Cloud, we solely do not offer a platform-based Vault functionality for storing your secrets, but I think the option using the HashiCorp Vault is still nice and still interesting because it also makes you platform independent. And yeah, that's today all from my side. So enjoy the next hour. And Victor, Ilya?
Yeah, I will take over then.
Oh.
Yeah, today's speaker, I hope most of you guys already know me. My name is Victor Getz. I'm the CEO and co-founder of ETS Consulting. And today I brought with me Ilya.
Hello everybody. My name is Ilya, also working as a DevOps engineer in IETS Consulting. Started like more than 10 years ago when FreeBSD was a popular system, and then continued as a DevOps engineer, basically. That's a short intro.
Ilya is the guy, if you need some very, very deep knowledge and some very specific topic, then he's my guy, and then just call him. And then, mostly times knows the answer. Is really surprising. So, yeah, it's very good to have him here today.
Thanks.
A little bit about our company. What does ETS Consulting do? We are founded in 2019, and we provide agile development teams as a service for cloud-native businesses, for Kotlin, Java applications, microservices. Every time it's complicated, then we are the best match. And we grew very, very fast because a lot of previous members in my teams joined my company, and now we have over 35 team members already, and just every month new members are coming. And yeah, if you need some help with setting up Vault or in your project, you need some experience or some technologies which we provide or services, then just give us a call. Today, we want to talk about HashiCorp Vault and Open Telecom Cloud. The previous two talks were like a short breakthrough through everything. Then we covered the whole Terraform stuff. And today we built on top on this Terraform knowledge. We will now build the HashiCorp Vault system for secret storage management system. If you did not attend our last talk, it's absolutely no problem because you will not miss anything. And if you have some questions on that, you can just ask them later or just watch our YouTube video. So what we will do today, we will present you today HashiCorp Vault on OTC. It is not some basic stuff because that you can see on YouTube or everywhere. We want to give you very detailed explanation what kind of experiences we made with the OTC and HashiCorp Vault or some other cloud provider, and so give you our best practices and our lessons learned, and also give you some blueprint which you can use later if you want to host the HashiCorp Vault system. So Ilya will make the short introduction. Then after that, I will make a short description how to host a high availability Vault system with Raft on the Kubernetes CCE. And then Ilya will explain some stuff about injecting secrets, which kind of solutions are there, and comparing them to each other. So when you're coming to the point that you want to set it up, then you know exactly what you can already use. Later, we have also a short summary about lessons learned and some links where you can get our code. So now I'll give over to Ilya.
Today's topic is about HashiCorp Vault and what is that. It's written there, secure, store, tightly control access to tokens, passwords, so on, and protecting secrets and any type of sensitive data using user interface, CLI, command line interface, or HTTP API. And we will focus today only on web UI and CLI, because we'll at least show how to use them and why is it needed, why it's an important topic. The reason is that modern applications need multiple secrets for proper work. These are secrets to SQL or NoSQL databases, bucket credentials, payment system, many other third-party APIs that are provided for our application. Some secrets could be generated automatically. Some other secrets could be obtained only by, let's say, responsible person. And Vault allows us to keep all those secrets in a central place and manage them in a convenient and secure way. So there's ability to automatically store or update them using automation tools like Terraform, Unsealing, many others, or edit them manually. Sometimes we need to manage and provide hundreds and even thousands of secrets for bigger applications with multiple integrations. So I guess that's why it's clear now why Vault is a very important topic to discuss today. We will talk about pros and cons. Yeah, pros, convenient. Vault allows us to keep all required secret in central place and get them once we've authorized. It provides predictable structure and paths where secrets are stored, and each secret in Vault is an object which contains key and value, like normal JSON or YAML object, which has Boolean strings, maps, lists, so on. So to get, and the predictable structure means it's very similar to what we have on our file system. So there are paths which contains, let's say, folders or directories, and some files like objects which contains data. So to get the secret, we need to authenticate in Vault and fetch the object by path. The convenience is that paths might be generated depending on how we agreed on, depending on our agreement on some conditions, like environment could be dev, test, staging, prod, and we can automatically substitute that in path. Might be related to application, location, like availability zone, and so on. It depends on our fantasy. It's reliable solution because Vault provides or supports high available installations. Normally, we should use an odd amount of nodes, for example, 3 of them, and Vault keeps and saves data on the storage in Vault. Terminology is named as a backend, and there are multiple backends supported right now. This means like all kind of databases and SQL databases, a lot of key value storages like Consul, etcd, Zookeeper, Cassandra, so on. We can store them in a file system, including S3 buckets, direct file system, or like integrated storage, which supports Raft replication algorithm. And in our case, we're using exactly integrated storage. We'll show you a little bit later why. About process secure, so Vault developers and architectures paid a lot of attention on security topic. Just for a very basic intro, it's all data saved encrypted, always. Not requires to unseal to start. That means that intruder can't even restart your service, Vault service, and upgrade his privileges. He needs to unseal it. All default communications are using, but by default for sure, HTTPS protocol, so it's encrypted on the fly. Tokens are also only temporary, except root token. We'll see it later. And just to mention some downsides of that solution is the restore process is not maybe, it's not complicated, but still it's not trivial. And for some reason, it depends on host name, and the new master of the cluster should have the same ID. That's won't dig into some details. For restoring in Kubernetes, we should use stateful sets to preserve names. The unseal process is normally the manual process, and it's quite annoying. Still, there is ability to auto-unseal, but we'll talk about later a little bit. And access management, it has some good permission management, but it's not overwhelming, I would say. So, for example, if you grant on a root folder or root path permissions, you can't restrict on the inherited paths permission. So this user will have access, the same access as to root folder. So, some words to Victor. Thank you.
Yeah, thank you very much, Ilya. Then we talk about how to host the system. Yeah, so we say, okay, we want to have a Vault system, and I want to have it high availability. That means we need at least to have 3 pods running on nodes or whatever, and I want to use Raft or whatever, and host it then. So yeah, we're beginning with the question is, where do I host it? So I want to have a Vault system, and the decision, the first one which you need to take is either you self-host it or you use some managed services, because you can just buy in a Vault service where there's a predefined and pre-installed Vault service, and then you can just use them. What are the benefits of a self-hosting system is that it's more secure. If you're doing it on OTC cloud, then it's a cloud hosted in Germany. You will not have some problems with the data somewhere is stored in USA or something like that. And this is like the biggest benefit also from OTC, that you are DSVGO conform, and so it's way much more secure than if you buy in the service. It's also easier to customize because you're not depending on a third-party company, and you can customize by yourself. And it can sometimes be cheaper. Often it is more costly than when you just buy the service, but it really depends on the scale and how much of performance and etc. you need. So it really, really depends. If you need a very, very small system, I think the managed service is way much better. Managed services, you can start immediately just by in the service, then you get the URL and you can start. You have also no chicken egg problem, like you building up something with Terraform, and the Terraform secrets you want to put into Vault, but you don't have a Vault yet because you host your Vault system on the CCE. So you don't encounter this chicken egg problem. And also you don't have no maintenance issues because the other company handles everything for you, maintains the service, and also you don't need to have some DevOps experience with that, so you can start directly. If OTC would provide such a managed service for Vault, I would be, I think, one of the first persons who will buy for our projects the Vault system, because it makes your life way much easier and you don't need to handle this chicken egg problem, which is like very complicated to do that. Okay, now you say, okay, I want to do self-hosted. Then comes the next decision, virtual machine versus Kubernetes. You can also make bare metal or something like that, but I would not reconsider it. I would make virtual machine or Kubernetes. It's virtual machines. It works better with console because we started with Kubernetes and console. We had some issues. There were a lot of logs warning that the Vault system could not find itself, and there were some other warnings which were not very crucial because it was just warning. And then when you read a little bit about that, this is just some health check which is wrongly developed, but it's all super annoying. And like if you're a perfectionist, it's not something for you then. And for me, it was also the case. And also, if you have some virtual machines, you have dedicated somewhere in some VPC away from your Kubernetes cluster, and you have less chicken egg problem. Yeah, but the downsides is that with Kubernetes, you are way much more flexible. You say, okay, I have now 3 nodes and I would like to have another one, and you're way much faster with Kubernetes. You don't have like the snowflake system with a virtual machine. And also most of the cases, if you're doing like cloud native, you have already Kubernetes cluster. So you don't need to add additional complexity on top. So you don't need to have the experience with I don't know what you use, Packer or whatever you use there. So you can just stick to the stack which you are currently having. And we also did everything with Kubernetes for all of our clients, and I don't regret this decision. What are other architecture decisions regarding hosting? Some of architecture also say maybe one vault for each stage, because you should keep every stage like dev, QA, and production very equal to each other. In my opinion, the idea is good because, for example, Kibana, Prometheus stack and stuff like that, we deployed on every stage to keep them, every stage is independent from each other. But in this case, because it's a central storage system, we have, for our clients, every time one vault for each of the stages. For one client, one vault system. Yeah, and it works very well for us. Because you have then also sometimes, very often, some manual secrets, some third-party secrets which you need to put into Vault. So you go over the UI and put it inside there, and so one Vault system makes, in my opinion, more sense to have less complexity, which doesn't bring much benefits. One thing is also when you think, okay, here I make it super tight, solid, and secure. So I have an internal Vault system which is publicly not accessible. Can sometimes be the case, but in 99% you would want to have also public access to put some manual secrets inside the Vault system. Yeah, and if you properly secure it with single sign-on or something like that, then I think it's in most of the cases it's also a good thing. KMS Auto Unseal is currently not available in OTC, in my knowledge. Maybe it will come. Maybe the OTC KMS key will also be able to do that in the future. So currently you need to unseal the Vault pods by yourself. But I will show you everything. We will build up everything. Do I need a high availability mode? I would definitely say yes, because yeah, it's every time good to have a high availability mode. And if you're using Vault, then you pay attention to security, and then you mostly need a high availability mode. I would recommend currently a Raft over Console. So if you're not currently using Console for a service mesh, I would highly recommend go with Raft, because we didn't incur so much trouble, almost no trouble with Raft. With Console, we had some issues, and it adds also more complexity. More performance is needed and stuff like that. And also, we started with a S3 bucket as a volume mount, but in our opinion and our experience, it was too low. There's also the, you can also use the S3 bucket as a storage backend, like not as volume mount, but as a storage backend from Vault. That can be quicker, but I don't know. We had some problems with the volume mount as S3 bucket, so we switched to SSD, and then it worked perfectly. Time for coding. So I want to set up with you today a Vault service hosted on CCE with 3 nodes. As a storage, we use Raft, deployed via Helm, and it should be hosted here under this URL. This is now what I want to do with you guys. So what will we do? We have 2 projects. One we have for Terraform and one for the Helm charts. So keep that in mind. We have one Terraform, Vault, one for the Helm charts. What have we already pre-configured? I will not build everything from scratch. If you made now the nodes and CCE everything from scratch, then it has not so much benefits, because you saw it already in last talk. So I'll build on top of that what we did last time. So we have a VPC, we have a cluster and the load balancer. And now on top of that, I will just install a Helm chart, this Vault Helm chart. Inside the CCE, I have already installed some Helm charts. So I installed the traffic for the routing, and I installed certification, set manager for the auto certification. So we get for our domain auto certificate. So here we have our Vault chart. It is dependent on the official Vault chart, and we have it a little bit configured here for our use case. So I added here some templates for the route. So for traffic, that we have some route under the host which we configure, and we get the auto certificate for our domain. So yeah, we disabled the agent injector. So we keep every time agent injector separate from Vault to keep it clear. what it does. So we configured here a little bit Raft. So you see high availability mode is on. We have 3 replicas. We have Raft storage. Then you need to set some flags like node ID enabled true, Raft enabled true. Here we have also defined the members of the Raft system. So we have 3 nodes here. And here's some data storage system and UI enabled. So what we'll do now is we will just apply the stuff. Apply minus charts Vault. I need to look if I'm on the right cluster. Yeah, looks right to me. You see here now that he wants to apply everything. This is the Helm diff plugin, which shows all the output. So we say yes here. The Helm charts in the repository, just read the question. We will put it in some Helm charts repository, so you can also get it from there. I applied now the Helm chart, and then let's just take a look what's happening now. You see there's currently containing and there's running. So what will happen now? I prepared here some Unseal SRs to a little bit explain what we need to do now. Ilya told already we need to unseal it so that you cannot get higher permission and just get the secrets or just to do something bad with our pods. So basically we need to unseal it. You see they are running, but they are not ready. So we look once in the logs, what does it tell me? It says here vault is sealed. So we need to unseal it. That's why we execute this one command here. It's in the official documentation of Vault also, so no worries. And what it does, it gives us 5 unseal key and 1 root token. This is the stuff which I have here. We have normally every time some convenience bash script. Also, I think we can also automate Terraform if you would like to, but it seems a little bit overkill for me. So we need 3 keys every time for every of our container to unseal it. So I would just set this inside the environment variables here. And what we are doing now is we executing some Kubernetes command to unseal it with this key. And then step after step, all the containers should be unsealed and available. So the first one is already available. Let's take a look. Key control and vault. Get pods. Yeah, the first one you see is already ready. So let's just take the next 2 one. Opa. So it's also available. Then we take member 2 or like 3. So if we say now kube control minus and vault get pods, yeah, you see they are all unsealed. Let's take a look if our certificates are already there. Get certificate, yeah, is already valid. So that means that if we access this URL here, vault minus demo, we should be able to access our vault. Nice. Let's take a look at inside the vault. What does it have? So I'm copying my root token and put it in here, and I'm inside. So I'm logged in. And I see my cubbyhole. Cubbyhole is for your private stuff. So you can put some private stuff here. Nobody sees it except for you. Here you can enable some new engines, for example, key value storage, certificates, but in most of the cases, 90% you use every time this key value store where you put key value pairs. Here on top, you have also access. Currently, the authentication method is just token, but we will fix that later. We have also some entities, but everything is currently like the basic setup. We have some default rules and stuff like that, and here's some random tools, but normally you just need this first part here. So we set up everything up. Now let's create the key value store. So let's just name it secret version 2. There's some also additional commands, and there are no secrets at the moment here, but we will change that later. So we set up everything up. So we have a vault with 3 nodes and 3 pods, and yeah, so we're done already very fast and quick. Yeah, but to have a vault system is very nice, but we need to configure it also. We need to define policies. Single sign-on would be nice. We need to put some secrets there, read some stuff from there. So that's what we will do now in this next step. So as an example, I choose now that we configure Vault like that we use existing Keycloak configuration and just log in over our guidance of the OTC Keycloak. We log directly inside our newly created HashiCorp Vault system. So how does the workflow work? So we log in the Keycloak. Keycloak gets a token for us. Based on this token, we then log into the HashiCorp Vault system, everything automated. Then we get the token from the HashiCorp Vault system, which has a limited of lifetime. And based with this token, we can get all the secrets and add also new secrets to the Vault system. We also defined it like this, that for example, our developers get every time they execute create Vault token, you saw it also in my last time talk, that they have access 1 week to all for them defined credentials, secrets inside the Vault system. This is currently how we use it. So this is really cool. So if somebody steals my notebook after 1 week, he cannot access any secrets anymore. Or I just block the user and he cannot access anything anymore. So what do we need for a single sign-on with Keycloak? We need inside Keycloak, you can also use any other OAuth provider. So Okta or whatever you use is also okay. So we need the client, we need some roles and some default scopes. And on the Vault part, we need a little bit more with GVT aus backend role and alias and stuff like that. But we will do it now. So we go step by step. For Keycloak. I configured it already because you need to, we do also everything over Terraform. We also configured Keycloak over Terraform. So what I did already, I defined one client, a new Keycloak client, where I put the Vault address in. So that we say under this address is a Vault system, and this one is permitted to interact with you, and so you have single sign-on over that. So we have this Keycloak client here. We define some user roles. So basically, the admin role should be mapped, and this client, like this new created Vault client, can read from the users the name, email, profile, roles, web origins, and groups. So that I did already to save a little bit of time. And now, like the important stuff, now I want to go into the Vault system and connect to our Keycloak. So what we'll do, for sure, we use just a Terraform module. So we have here, I copied one of our stuff. This is the Keycloak OEDC. And here some GVT aus backend, the Keycloak. And here we define that if you log in over Keycloak, we get a Vault token, which is valid for 1 week. These are the 768 hours. And here we define also the scopes again, or OpenID, profiles, roles, groups, and email we need. And we also make here mapping. So basically, if you are admin inside Keycloak, then you're also an admin in the Vault. And what kind of permission does have the admin from the Keycloak have? This one we defined over some Vault policy. So basically, the admin from the Keycloak has permission to do everything with secret / everything which lies under secret. This is the secret storage which I created just manually. And also authentication he can change, system, and basically you can do everything. So you can find granular, also define what the user group inside your Keycloak or OEDC can do and whatnot. So let's apply this module. So I will uncomment this part. So I will just use this module. I need to provide the Keycloak URL. This URL here. I need to provide the Vault address. This is our newly created Vault address. Here I also provide the client ID secret. This is what you never would do like this. This is just a demo case. And we will just tear it apart after the talk. So, but normally you put Vault and Keycloak. If you have just one Keycloak for all the stages, you put Vault and Keycloak inside one stage and just use the secret then from Terraform. So it would be something like module.keycloak client secret or whatever, vault client secret. And the client ID from the keycloak I need to provide, and that's that one. So let's apply it and try it out. Terraform apply minus target module dot. And we use here the vault provider. So basically it should change inside the vault. But I made one mistake. I need first to set the vault token. I forgot here, because otherwise he would get go to the wrong vault, which I use by default. So I need to export this vault address, like the newly created vault demo. Otherwise, you go to the other vault system, and my vault token I will provide here. Normally, you use then the keycloak if you want to set it up, and also you automate normally the process. But it's way too much to do for this talk inside 1 hour. Minus target module and this one.
Probably auto token, Victor.
Did I copy the wrong one?
Yeah, you didn't copy it from WebUI.
Oh, yeah, you're right. Yeah. Thank you, Ilya. So this is the right one. And try again. So basically he said vault token lookup self. He said I'm not permitted to do that. But now it works. So I used the right token. And now he should create me the single sign-on. So press yes. And he created the vault. He configured the vault system for me. So if we go back again, I'll here sign out and refresh. You see here is keycloak as a new part. And here we have sign in with ODC provider. And you see here Guardians of the ODC. I can log in myself. Voila. And I'm logged in. And I have access to my secret here, which I created new. So let's check the policies, because we are admin, but we are not the root. So basically, if I create here a key value store, which I'm not permitted to use, then basically I should not see it, even if I create it. So I create here, not permitted, enable this engine. You see, I'm not even seeing that. Even if I just exited over the UL, it says not authorized. Why is that? Because we created this new policy with the admin policy, and it's not inside this list of capabilities. That's really, really cool. So we have a single sign-on of a keycloak, and we have also different tokens. So if I copy this token, you see this one is different from that which I used before. So this is this one, and this one. This is the root token. This is my new keycloak token. I think it was token lookup then, yeah. Lookup. Ah, there we have it. You see here. This is the creation time to live. The display name is from keycloak, Victor Getz. He got it from keycloak, my name. And here's also my policy, admin, and everything which describes this token. So it's really, really cool. So that's the part for configuring over Terraform. And it should give you a very good short introduction. So yeah, our next topic would be how to backup raft storage. But it's also very interesting now, how do I put data inside, yeah? Like how to do it with Terraform. And that's why we preferred also something. For example, you have now a load balancer and you have a LB ID, you have a kube control config. I preferred here also some module. So basically what I'm doing under secrets and then var stage name, currently I think it's presentation or something like that. Then we want to create here new vault secrets. I want to put inside my vault my kube control config and my ALB info, my elastic load balance info. So I'm getting this information from my modules, and I would just apply again. He's refreshing the state because he needs to read the information from the LB ID. Maybe it's changed, and also needs to read the kube control config. And my internet is not the fastest. So press yes. And if we go back to our Vault system, we see here Vault demo was our stage name. We have here all LB info. And here we look at the inside JSON, and you see this is my LB ID. And we have here also kube control config. Really cool. So let's talk about backup, because this is your central system that needs to be uptime 100% all the time. So what we do, we back up the data every night. So we have for half of year, we have we can go back to every day, and we have also auditing enabled. So basically we can see every time when somebody logs in over Keycloak or over root or something like that, when he changes the data, it gets logged, like what was the previous data, what is the data now, and who made the change. This is really, really cool. And we have Kubernetes cron job running for that. He backs up all the data from SSD to OBS bucket every night. One solution could be also for you to use the volume backup service from OTC. In our case, since we are providing not only service for OTC, but also for different cloud provider, that's why we use an independent setup. That's why we went with Kubernetes cron job. And yeah, it works very well. So now I give over to Ilya, who will tell us a little bit about how to inject then the secrets.
Yeah, thank you. Basically, we were thinking what are the ways to inject the secrets at all, and found that there are only 3 ways there. The first one, when application by itself knows how to connect to Vault and use its API to grab secrets. And probably if we are developing our own very secure application, which we should certify with kind of PCI DSS, that might be the best option, but I will try to point on disadvantages of each method. And this one, those disadvantages are that this could be related only to self-developed application, and most probably we will not find open source or some vendor-specific applications which will support such secrets injection. Other disadvantages are that this will add some complexity to the development and probably will create kind of vendor lock, because we will be dependent of Vault solution. Still solvable, but just some obvious stuff. The second one is configuration files. And there are 2 approaches there. Both are not perfect. Both sides have pros and cons. And either we should store entire config in Vault and grab it, or we should use a kind of template engine, and there is no standard for that approach. And this works perfectly when we have a kind of virtual machines and deployments there. Probably very native approach. And the third approach is environment variables. Probably that's the best approach for containerized environment, like Kubernetes, for example. Hardly manageable for non-containerized like virtual machine, like native applications there. And one of the disadvantages is that very big configurations with hundreds and thousands, I would say, environment variables could be the limitation there. We know that the environment variable size limit is something like 64 kilobytes. So just to take that, keep in mind. Next, what are the ways to inject secrets in our case? We will focus only on environment variables, just not to waste a lot of time, and Kubernetes implementation there. And the easiest, like the reliable and the most ugly, I would say, way is to inject them in, let's say, pipeline. So on the right side, we have the pipeline, which is running. On the left side, we have a kind of secret part or secret YAML, which is the part of our deployment, Kubernetes deployment. And here we have the very primitive substitution or templating engine with nsubst, where we are governing, where as a first line we are logging into Vault, preparing Kubernetes config, then fetching using Vault kvget, that's the CLI util, secrets for specific on specific path, and then using nsubst, generating the deployment YAML and applying it. Why it's like ugly? Because there are other solutions which allows us to integrate, for example, GitLab directly with Vault, and in this case we could expose environment variables directly from the pipeline without that dirty tricks, but still that will work everywhere. So just to mention it, there is another other side approach, is the Vault agent injector. So just for basic understanding how it works, in Kubernetes we are launching pods, not the containers, right? And launching pod, we can add init or sidecar container inside the pod. So each time we are launching our application or pod, there are at least 2 containers there. And the first one is launching the Vault agent injector. It grab required secret from Vault and save them on the file system, which is shared between containers inside the pod. And that way, our application got the secrets. And here is the simple explanation or example how it's done with the Kubernetes deployment. There are annotations which are managing how we will handle secrets. So we would work as an agent injector or not set true. The role that should be used for authenticate us in Vault on the line 6. Line 7 managed the it can renew or restart pod if the secret was changed. So in this case, it's true. And the path where we should grab secrets to be injected. In line 9, this provided a kind of templating engine to export different variables per secret, because on that object we might have a set of secrets and we will want to export all of them, like it's written here on line 13. And the end of the annotations is like executing those secrets to export them. So we can use those files as the config files if we wish, or we can export them as environment variables. To talk about Vault agent injectors, also pros and cons. A really great pros is provided by HashiCorp, and it's native way to inject secrets in our containers. Much safer than secret environment variables. Basically, what it does mean is that we can inject secrets on the container start, and then we can just drop that directory at all. Environment variables will be visible only for running process inside the container. So even if we will jump into the container, we won't be able to see secrets in the environment variable. And the transparent for deployments. Basically, developers or admins might not know how they will inject the secrets. It just works. It's not in the pipeline. It's not in the code. It's like just creates secrets in the specific path using some magic. Cons. That is complex solution, which requires a lot of configuration on every side, on Kubernetes side, on Vault side. We should create policies, and so on. Just want to mention that that is cool solution. We are using that one for our projects, but again, not to waste time and not dig too deep. We will focus on more simple stuff, just to, as a showcase. So for the time for coding, what I did before, I created a database in that project and added there some data. This data was it's just a table that contains a sentence, and wrote some tiny application which just randomly grabbed the sentence and shows it on the page. Just let me show it here. So here's the tiny application. We need to provide to that application MySQL credentials. Then it will select a random one and print it to the page. I build the container and push it to the public Docker Hub registry. And now I created a SQL database with Terraform. So let's try to apply it. It's already created because it will take something like 6 or 8 minutes to create database, but we will reapply it again, and the cool stuff, we will save with that command our credentials on the Vault. So currently we have only fake data there, or fake secrets. Now we will have real secrets in Vault. It's done on that part, on modules, MySQL, and so here's the code which is creating our instance, and then we are just using resource Vault generic secret to save the secret in database. What we see here. Yeah, we have 2 secrets here. Now let's try to apply our Terraform code here. It's thinking a little bit. Yeah, I need to authenticate in Vault. Sure. So it's copied. Vault token is saved in the whole directory of user. And let's try it out. Vault list secret, which was created by. Okay, nice. We have now connection. Apply. So only one element will be added, and it's done. So Vault demo our root folder, and here we have MySQL secrets now. On the JSON format, it looks like that. We can view it as a secrets there. Right, now let's try to deploy our application. Yeah, I've created that, as I shown before, that's just one single PHP file, but Helm chart was created by me this morning using Helm create showcase app, and it contains just a very trivial stuff with values. Yeah, we have two replicas. Here I just pushed my Docker image. Nothing special. Yeah, we're exposing that port. And the interesting stuff is here. So we need to substitute those secrets or configurations with values from Vault. Yeah. And for that, I just prepared one tiny shell script, which just fetched those secrets like from as a command line with you, CLI, using GQ, parse data, and set them before or injecting them into values. So let's try to launch it. Debugging currently with a shell script, so we can see all the stuff. So let's look. Something, yeah. Here's our pods running. Meanwhile, one was started before. We even have a service for that. So let's try forward service. It's working. Right. Localhost 8080. Yeah. This line, this string, was fetched from MySQL as a random one, and just shows us a kind of lame excuse of such operator. Each renewal will get us, will provide us a new lame excuse. Right. That's it from my side. That was a very simple showcase, but I guess it should be enough for the intro. Victor.
Yep. We are almost through now. Like we have just one more step to do. It's some other solutions and best practices. So basically what you can also do is, if you're familiar with Azure Cloud, then you can also use Banzai Cloud. So basically create a secret and then make some annotations there, like I'm currently showing. And it's really easy to use. You can also use multiple vault target systems, which you can not so easily do with agent injector. So you see in the first line that there is a specific vault address, but the cons is it's not secure because, yeah, the Kubernetes secret is not secret if you do some additional stuff and encrypt it. So yeah, it's every time depending on the client and every time depending on the project. If you're, for example, in health or finance or something that you need to have it very tight and solid, if the data is not so important, then you can maybe also use such a thing. Yeah, let's talk a little bit about lessons learned. For seed initial data from third-party systems or something like that, we often set up some seed project, Terraform seed project. It's very important that you encrypt also your TF state, because it was also in the chat, because the secrets stay also in the Terraform state. So please encrypt your Terraform state. Vault plus console on Kubernetes did not work for us so well, so we switched to Raft, and since then, over half a year, no problems. Everything worked super well. Agent injector is very complicated. It's very tight, very solid, and very secure. But yeah, it's very complicated to use if you don't have the experience with that yet, and if you don't know how to set it up, it can cost you a lot of time. OPS bucket speed limitation is when that was the mounting, which I mentioned. So better use SSD if you use the volume mount. And again, without proper knowledge, the Vault setup can be very challenging because we just covered, I think, 10-15% of what Vault can do. And there's a lot of more stuff. And if you need some support, just contact us and we can help you. Because all of this agent injector we used already in our client situations, and we have a lot of projects where we use Vault, and so we have a lot of experience. We are also certified HashiCorp partner, so yeah, we can help you out with that. What's next? So again, this link for Open Telecom Cloud Project Factory. So basically every module which we use now, it will become public and it will become even more stuff will be public. And the Project Factory will be the basic setup with CCE, VPC, and also load balancer. And some very, very basic stuff we will export there. And then around that, you can also add just additional modules which you would like to have. And then next week it will be also available under the public registry Terraform.io. That was it from my side. So I will give over to Uli.
Thank you, Ilya. Thank you, Victor. Also from my side, a very nice and really interesting and awesome session today. Also, thanks to the participants which joined today. And back to the Stefan.
Yeah, thank you for your closing words, Uli. So also from my side, thank you to all of you who have joined today here in this really, really hot day, hot evening. And with this, I would say, let's close this webinar. When you have any questions later on, just put them into the OTC community portal. There, Victor and the whole ITS guys will be there to solve your problems, to give you some hints. And by this, thanks a lot and see you in the next webinar. Thank you a lot. Bye.
Thank you. Bye-bye.
Bye.
Bye-bye.
Thank you.